Hello everyone, my name is Dawid Rybak. I'm a first year PhD student at the University of Liverpool. Our planet is continually cooling through the migration of hot, multi-phase magmatic fluids upwards through subsurface plumbing systems. High infallibility geothermal resource development tries to exploit this inevitable process as a source of sustainable energy. Heat replenishment of geothermal reservoirs is relying upon fluid migration in an open interconnected fracture network. However, fluid migration through hot host rocks can provide ideal conditions for the minerals to nucleate, causing fracture sealing, reducing permeability, and therefore geothermal energy production. The real-time physical and chemical processes related to coupled fluid fracture interactions within these reservoirs are difficult to encompass due to the inability of observing these dynamic interactions in situ. To bridge the gap, our method of approach is of an experimental one. The aim is to advance the understanding of dynamic interactions between microscale chemistry, structure, and fluid dynamics, and their control on mineral nucleation and growth. An expected outcome for this research is to assist the geothermal industry to identify signals by which physical and chemical fluid rock interactions divert the system out of equilibrium and into unfavored reservoir conditions. Firstly, using laser imaging and 3D particle image velocimetry and digital image correlation during fluid injection to pre-fractured translucent crustal analog material will enable recording of the physical dynamics of fluid flow and rock displacement. Quantitative recording of stress interaction and disturbances allow to observe how these affect fracture fluid dynamics. Second set of experiments will involve generating a suite of synthetic hydrothermal veins in fractured rock samples of ancient and active geothermal reservoirs under variable fluid flows, temperature and pressure conditions. Mineral chemistry and orientation and morphological texture characterization of the experimental product will help to identify dominant mechanism at the atomic scale that govern mineral nucleation and growth at the fracture fluid interface. Thank you very much for listening.